Okay, welcome back, students. We will discuss a very important and very, uh, you know, unpopular, you can say, topic in mathematics. And the area of concern here is, let's say around 9th, 10th standard. Okay, so significant figures is the topic. Okay, and it is related with the number system. Okay, so let us understand where exactly this is applied, or where do you get questions with regards to significant figures, and how do we interpret what are significant figures, and how do we solve questions involving such things. Okay, so significant figures, please remember, is the topic. Now let us see what is the relationship in which these are used. We have heard something which is known as, let's say, mm, rounding off. Okay, we have heard rounding off of numbers. Okay, rounding off of numbers. So now what is this rounding off? Let's say, for example, I have a digit, a number, let's say 99. Okay, this is an example. Now this is a pretext to significant figures. Right now I'm not discussing significant figures, but I'm discussing something which will help you understand the concept of significant figures. Okay, so let's say, for example, I have 99 as a number. Okay, now if the question tells you that you are supposed to round this number off to the nearest 100. Okay, now please note, children, that the question is that we have to round off this number 99 to the nearest 100. Now nearest 100, if you go to the right of this, the immediate next number is 100, and if you go to the left of it, you have 0. Okay, I mean, I'm not talking about the immediate left number, but I'm talking in terms of hundreds, because the question is rounding off to the nearest 100. Okay, so to the left side and to the right side, the difference of 100 is giving you 0 and 100. So is 99 closer to 0, or is 99 closer to 100? So the answer quite simply would be 100. Okay, so when somebody asks you round off 99 to the nearest 100, your answer would be 100. Okay, so after rounding off 99, your answer would be 100 according to the question. Okay, now if somebody asks you, let's say, let's take up another example. Let's say, for example, somebody asks you 49. Okay, suppose that 49 is the number. Okay, and you have to round it off to the nearest 100 again. So on the left side you have 0, and on the right side you have 100. Again we are talking in terms of rounding off in to hundreds, nearest hundreds. Okay, so the nearest 100 on the right side here is 100. Okay, so is 49 closer to 100, or is it closer to 0? So this time your answer would be that 49 is closer to 0. In fact, 50 we all know is the midpoint of 0 to 100. Okay, so anything beyond 50 would come under this category, lesser than that would come under this category. Okay, so this is rounding off to the nearest 100. Now suppose in the same question somebody asks you round off 49 to the nearest tens. Okay, this time we are rounding it off to the nearest tens. So on the left side of 49, the nearest 10 is 40, and to the right side of it, the nearest 10 is 50. Okay, now this time I have a gap of 10 10 each, because this time we are rounding off to the nearest tens place. Okay, not the hundreds place. Okay, so is 49 closer to 40, or is it closer to 50? So the answer again quite simply is this. So if you want to round off number 49 to the nearest tens, then the answer would be 50. Okay, so as far as the whole numbers are concerned, this was the idea of rounding off. Now suppose that you have a decimal. Let's say, for example, 15.62. Okay, this is the number 15.62, and they're asking you to round off this number up to, let's say, up to one place of decimal. Okay, so we are supposed to be rounding this number off up to the first place or the one place of decimal. So the first place of decimal is this. Okay, so your answer should end after the first digit after the decimal. Okay, so your answer cannot go in two decimal places. Okay, so what we will do is, if we want to round it off to the first decimal place, so the number has to be in 1 2 3 digits till here. So we have to look at this digit. Beyond the first decimal, I have to look at this digit. So if it is less than 5, which it is in this case, so the answer will remain as 15.6. Okay, this will be the answer. But had this number been, let's say, 15.65 or 15.66 or 15.67, so let's say again the question is round off 15.65 to the first place of decimal. So in this case, this is that extra digit, we have to look at it. It is 5. If it is 5 or greater than 5, then you increase this number to the next number or by 1. So your answer this time would become 15.7. Okay, instead of 15.6 like in this case, it would become 15.7. Why? Because that extra decimal digit beyond the first decimal digit, the extra digit that we have over here, it is 5 or greater than 5. So this number has to be increased by 1. Okay, so this is something that you already know. Okay, now we are going to go to the topic that we had to discuss here, which is significant figures. So let us understand what significant figures are. These are not difficult to understand, but students generally have a tendency to forget about it. So as far as significant figures are concerned, we have a few rules in place. So if we keep those rules in mind, it will be very easy for us. Okay, so let's say let us talk about a number first. Okay, so let's say I have 0.00402. Okay, now that there is a particular reason why I have selected such a number. It has decimal also. Okay, as you can see, it has a decimal also. It has some zeros which are known as leading zeros. Please understand this, children, very carefully, because it is these terms that the rules are related to. Okay, so these are known as leading zeros. Okay, leading means they are in front. Okay, so if these are if this is your entire number, what is coming in front? These few zeros are coming in front. So any zero which leads the number, they are known as leading zeros. Then certainly you must have understood what this zero is. This zero is going to be called as trailing zero. Okay, because it is coming at the end or the back end of the number. So this is known as trailing zero. Now this trailing zero can be more than one also. If I put another zero here, we will call those two zeros as trailing zeros. Okay, so trailing is coming at the end, leading is coming in the front. Okay, now look at this zero here. This zero, it cannot be called either a leading zero or a trailing zero, because it is neither in the front nor at the end. It is in the middle of two non-zero digits. You can see that these are what we call as non-zero digits. Okay, non-zero digits. Okay, so there is a zero which is coming in between the two non-zero digits. So they are known as, such zeros are known as captive zeros. Okay, captive zeros. Okay, so in this case it is only one, so I'll write captive zero. Now captive word means that somebody is holding someone in a fixed place. Okay, so it's like capturing something, not allowing it to move anywhere. So who is capturing this zero? 2 and 4, these two non-zero digits, they have sandwiched this zero in between themselves. Okay, so therefore this zero cannot escape anywhere, if you want to understand it like that. So this zero is held captive, or it is held in captivity, in prison, let's say, between these two non-zero digits. Okay, so I hope you have understood the term leading zeros, trailing zeros, and captive zero, because our rules are going to be related with these terms. Okay, so if you have this in mind, let us now go to the rules. Okay, so the rules are this. I'll take up some examples and help you understand very easily how to judge the significant figures. So let us say the first rule is all non-zero all non-zero digits will be counted. All non-zero digits will be counted. Now, as such, this statement would not be making much sense, but when I will take this example, you will understand it very clearly. Suppose I have two numbers here. Okay, so I have a number 26. Okay, so this is a number given to me, and the question is, find out how many significant figures are there in this 26. Okay, how many significant figures are there in 26? So the rule is all non-zero digits will be counted. So in this number 26, how many non-zero digits are there? You can see both digits are non-zero. There is no zero in the number. So the number of significant figures will be 2 in this 26. Similarly, if you take up a decimal number example, we have 2.86, and the question is again, find out how many significant figures are there in this number. So all non-zero digits will be counted, whether it's a decimal number or a non-decimal number. Count the number of non-zero digits. So 1, 2, 3. So the number of significant figures in this number is 3. So decimal does not dictate terms here. Okay, so as far as non-zero digits are concerned, all the non-zero digits will be counted if you want to know the number of significant figures. Okay, so that is the first rule. Now let's have the second rule. So let's say let me write this down here. Now you see, we have spoken about the non-zero digits. Now let us talk about the zero. What if, you see, you cannot always have a number without any zero in it. Okay, there is bound to be a number which may have zero also in it. Okay, so let us know this rule now. All leading zeros. Now you see this term leading zero is coming. So all leading zeros do not count. So the important term here is do not count leading zeros. Now again, this statement would be making less sense. It will make more sense if I take up an example. So let's take that example. 0.0025 is my number this time. And again, the question is, how many significant figures are there in this number? Okay, so now you see, look at the first rule. All non-zero digits will be counted. So these two digits certainly will be counted because they are non-zero. Now talk about these digits. Can we count these digits also in significant figures? All leading zeros do not count. You all know that these three zeros are going to be called as leading zeros because they are leading, they are in the front, so they are not to be counted according to the rule. Okay, so how many significant figures does this 0.0025 number has? It has only 1 and 2 significant figures. Okay, clear? Let's take another example. We have, let's say for example, 030. Okay, I have this number now, and again the question is, how many significant figures are there in this? So all non-zero digits will be counted. So non-zero digit is this digit, it will be counted. This is a leading zero, so it will not be counted. And this is a trailing zero. Okay, so trailing zero, we have not yet discussed that rule. So let us introduce that rule now. So what is that rule? Let us erase this and then understand on a fresh page. So let's say that we have the third rule in play. So the third rule is all trailing zeros count if, so there is a condition, count if the number has a decimal in it. Okay, now you see there is a condition. So this is that condition, all trailing zeros. Now what do you mean by trailing zeros? Let's say, for example, we have a number, let's say, okay, let's take this example, 2106.0, or let's say 2116.0. okay, this is your number. Okay, and again the question is, how many significant figures are there in this question? So are there any leading zeros? No. Are there any non-zero digits? Yes, 1 2 3 4 non-zero digits are there. So according to that first rule, all these four will be counted. Now comes this particular zero, which is the trailing zero. It is the trailing zero. Okay, so what does the trailing zero rule say? It says that we will count that zero if the number has a decimal in it. So is there a decimal in it? Yes, there is a decimal in it, therefore it will be counted. So the number of significant figures in this question is 1 2 3 4 and 5. 5 significant figures are there in this particular number. But if I choose this number 21160, okay, now I have removed the decimal from the number, so my number is 21160. So what is that rule? Go to the first rule. Are there any leading zeros? No. Are there any non-zero digits? 1 2 3 4. So I will count all the non-zero digits. Is there a trailing zero? Yes, there is a trailing zero, but it will be counted only if the number has decimal. This has no decimal in it, therefore the zero will not be counted in the significant figures. 1 2 3 4. This has only 4 significant figures in it. Okay, so this is a very good example where in one case a trailing zero is being counted, and in another case the trailing zero is not being counted in the significant figures. Okay, now comes that last rule in which you can have a zero in between the non-zero digits. Okay, so that will be the captive zero case. Okay, so let me take up that case also, which is the last case. So we have that fourth rule here, all captive zeros will be counted. All captive zeros will be counted. Okay, so will be counted is the main theme here. So let us take up an example again to make it more clearer. In fact, we will take two examples. 0.5025. Let's say this is your number. Okay, so again, are there, let's go to the first rule, the very first rule. First rule said all non-zero digits will be counted. So non-zero digit, non-zero digit, non-zero digits. So we will count these 3 digits certainly, first thing. Then comes, are there any leading zeros? Yes, you can see there is one leading zero. So leading zero will not be counted according to the second rule. Okay, are there any trailing zeros? No trailing zeros, so that third rule does not apply here. Now comes this last and the fourth rule. All captive zeros will be counted. So this zero is a captive zero, because as I told you earlier, captive zero is a zero which is captured, which is continuously held under capture by two non-zero digits, so it will be counted according to this rule. Okay, so this digit to be counted, this 1 2 3 4, so this number has 4 significant figures. Okay, I am sure that this would clear most of your doubts regarding significant zeros. Let's take up one last example of this same kind. Suppose I have let's say 10.05 as a number. Okay, and I want to know how many significant figures are there in this. So any leading zeros? No. Any trailing zeros? No. Non-zero digits? Yes. 1 and 2 non-zero digits. What about captive zeros? 1 and 2. Both these zeros are held in between these two non-zero digits, so they will always be counted. Therefore, 1, 2, 3, 4. This number has 4 significant figures. Okay, so that is the crux of the significant figures aspect of the game. You may have to go through this lecture once at least after you have gone and have a cursory look, because you need to understand, if you need to understand significant figures and remember them for future use, you will have to go through this entire lecture without fast forwarding it. Okay, because the examples that have been taken up, they have been taken up to cover all the cases. Okay, so I'm sure this will help you in your board exams also.